Welcome to solverfy.
(13.52) we want to figure out whether a 5,000 kilogram elephant exerts more pressure on the ground than a 50 kilogram person wearing stiletto heels. Now, I'd have no idea how big elephant feet are in terms of like a number. But there are two things here. First of all, they definitely have much more area that they act over than stiletto heels, and also the elephant has 4 feet, as opposed to people, which have 2 feet. Who have 2 feet, whatever. And since we're talking about pressure, the surface area is as important as the actual weight. So what we can do is just think about what the area of one has to be in terms of the area of the other in order for the pressures to be equal. So there are other ways you could do this. You could take a stiletto heel and measure its contact area, and then you could look up what the diameter of an elephant's leg is and so forth. But if we get that sort of depending on what we get in terms of the areas, if it's clearly much less than what the size of an elephant leg would be compared to a high heel, then we can tell that the elephant exerts less pressure and so on. So the pressure for the elephant is going to be the force divided by the area. So the force is going to be the mass of the elephant times g divided by 4 times the area per foot. Or you could think of it as 1/4 of the weight of the elephant divided by the area of 1 foot, but obviously you get the same either way. And the pressure for the stilettos will similarly be F. This will be the mass of the person times G divided by 4 times the area of the shoe. No, I just said people have 2 feet. So 2 times the area of the shoe. So now if these were equal, then we'd have mass of our elephant times g divided by 4 times the area of the elephant foot would be equal to the mass of our person times g divided by 2 times the area of the shoe. So g cancels. And so this means that the area of the elephant's foot divided by the area of the shoe, let's see, so we move that over here. So we'd have a 1/2 because we multiply both sides by 2. And so 2/4 is 1/2. We have a mass of the elephant divided by the mass of the person. So this is 1/2 50,000 divided by 50. So this is 500. So if the area of an elephant's foot is 500 or less times the area of the contact for a high heel, then the elephant would exert the same or more pressure. And areas can be a little bit tricky to reason about because they go like length squared, and so it makes things a little bit weird, since the most intuitive thing for us to think about is lengths. Volumes are even worse in this regard. And so if we take the square root of this area ratio, we get the length ratio we would need. So the square root of 500 is about 22. And so if you consider the sort of length of a high-heeled sort of contact area versus however big an elephant's foot are, I would not be surprised at all I'd actually be surprised if the elephant's foot were less than 22 times the sort of diameter as the sort of characteristic length scale of a footprint. And if you'd like, you can look up actual numbers again for how big an elephant's foot is, and then make a guess for a shoe, because that's a little bit, you wear shoes every day, or you can at least get a hold of one and measure it. And considering that the actual contact area for the heel in a pair of stiletto heels is maybe like a centimeter squared or something, and most of the weight is supported on the heel. But anyway, if you sort of do a more rigorous calculation than the one I've done here, you'll find that it definitely exerts less pressure. And from the argument I've given here, we can be pretty sure that this is the case without having to look up a whole bunch of stuff that we might have difficulty finding.